Hello everyone, welcome again to my YouTube channel, Python All Day, Python All Day. This is where we talk about anything and everything Python, and we are very excited to have you, and be sure to subscribe as so we can be able to dig deeper into Python together. But we're very excited today to talk about Python lists. And in Python, list is one of the most fundamental data type in Python. And literally, if you're going to do programming or software development with Python, you are going to most definitely find lists to be very, very useful. One thing to note is that in Python, a list is an ordered collection of items where each item or element has a position in the list. We start with position from 0, index 0, indexing. Each position is an index, and we start with index 0, 1, 2, 3, like that. And we'll see that as we continue. And Python lists are highly versatile, and they can store multiple data types. You can store integers in a list. You can store floating point numbers in a list. You can store dictionaries in a list. You can also store other lists in a list, and we'll be able to see this as we continue in Python. So essentially, you can store any other data type in a list, and that makes a list very versatile to be able to utilize during your software development or even programming or writing scripts in Python. So key properties of a list is that, number one, they are ordered, and the order in which the elements are added is typically maintained. Number two is that they are mutable, meaning that lists can be modified upon creation. You can modify the list after you create the list. You can add, remove, and also change items in a list after you have created it. That's what we call mutable. Mutable. You can change items in the list after you have created the list. And also another thing to note is that lists are typically heterogeneous, meaning that lists can hold items of different data types. As we have seen, they can hold integers, floating point numbers, complex numbers, strings, other lists, dictionaries, sets. So that is another key concept to understand when it comes to lists. And the other thing to note is that lists normally allow for duplicates. You can have duplicate items in a list. This is as opposed to sets which do not allow duplicates. How do you create a list, you ask? Creating a list is actually very easy, and we can just do that with a single line of code. I can have here my list. I can call this my list, and I can assign this to square brackets like that. And I've just created a list, just that simple. It's an empty list, but it's also a beautiful list. And that's how you create a list in Python. That's a list. You use square brackets. And now in my list, I can put anything I want to put in here. I can put an integer, 1, 2, 3. I can put a floating point number. See how when we put items in a list, we separate them with a comma, with a comma, with a comma, with a comma. So that's one concept that I also wanted you to be able to understand, especially when we are creating a list. We separate items inside the list with a comma, whether those items are integers, floating point numbers like 0.98 or 0.45 or 1.5. We separate any item that you put in a list with a comma. If you want to have another list inside this list, again, we can have another list, and this list can have a string called hello world. And again, we separate every item with a comma. And I misspelled world because sometimes you never know what you're typing, and that's how you get bugs in your code, and you wonder, what a simple thing that I forgot. But that's how you create a list. You can also have a dictionary here. You can say the key to be name, and the value to be, I need a dictionary. Dictionary, we use curly braces. My bad. We use curly braces like that. We can have a name here, and we can have the value to be John. And we can also have an age in this dictionary. We can have age. We have to put quotes in this. And we can have the age of John to be 25, like that, 25. But again, the concept is every item in a list we separate with a comma. So we have every item in the list separated with a comma. But this is a beautiful list. It's a list that contains integers, floating point numbers. It contains another list with a string in it called hello world. It also contains a dictionary with a name, the age, and we can actually also add here whether John is married. We can write married, and since he's only 25, we can maybe say false, like that. We can say false. But that's a list. If I print this list, I say print, and I print my list, and I click on run, then I have my list here, and this is a list that contains integers, floating point numbers, contains another list in it. This is the other list, and the other list has a string in it with hello world. It also contains a dictionary. Remember, dictionaries have curly braces, and they are key value pairs for dictionaries. And we have in the dictionary, we have a name, and the name is John. We have an age, and the age is 25. And we also have a Boolean type, whether John is married or not. And in this case, we wrote that it's false, meaning that John is not married. But that's how you create a list in Python. And also this illustrates the concept, one key property of a list, that we said lists normally can contain different other data types in them. We can also have things like a set in it, or any other thing really that you want to be able to have in your list. So that's how we create a list, and we've seen that example. Now the question is, how do we access items in a list? Suppose I wanted to access 3, or I wanted to access hello world, or I wanted to access the contents of this dictionary. How do I access contents in a list? And an easier way, you can access items in a list through their index. Like, remember, items in a list, their position is denoted by the index. This is index 0. We start with 0, index 0, index 1, index 2, index 3, index 4, index 5, index 6. Hello world is index 6. Remember, the comma separate the items in the list. And this is index 7. So if I wanted to access index 7, I could just come here, print my list, and the way you access an index is you put in square brackets like that, and you write the index like that. And if I click on run now, I'll get this index 7. Remember, the index 7 is the whole dictionary. So if I click on run, then I get the whole dictionary with the name, as John, with the age as 25, with married equals to false. That's how you access an item in a list. If I wanted to access the 1.5 here, I start again with index 0, 1, 2, 3, 4, 5. So this is index 5. I can just come here and I say print index 5, and I will be able to get, I'll be able to get by 1.5. If I wanted to get 3, then I have index 0, index 1, and index 2. So 3 is index 2. And I write there index 2, and we click on run, and we have our 3. So that's how you access items in a list. It's pretty much by the index. You can index items on the list. You can also access items from a list by using slicing. By slicing, you get a slice of the list. And the way we do slicing is that we specify where we want to start and where we want to end. There's also another, you can specify the step or the stride, how much you want to skip as you access the items in the list, but we'll talk about that a little later. But to slice, like for instance, if I wanted to get 2, 3, and 0.98, so I can come here and I say the index where I want to start my slicing. In this case, this is index 0, 2 is index 1. So I say I want to start at index 1, then you put a colon, then you say the index where you want to finish your slice. So I have index 1, that's where I want to start, and I want 2, 3, and 0.98. So I want the index for 0.98, but since I want to include 0.98, the end in index is not inclusive, it's exclusive. The starting index 1 is inclusive, but the ending index while slicing is exclusive. So I have 1, that's inclusive, 2, 3. So 0.98 is index 3, but since I want to include the 0.98, I have to go 1 index more to index 4. So I can say index 4, and if I click on this, we have 2, 3, and 0.98. Remember, 0.98 is index 3, but since the ending index when we are doing slicing is not inclusive, or rather it's not included in your slice, you have to go 1 index more. So in this case, even though 0.98 is index 3, we went to index 4 because index 4 will not be included. And if we want to get from 2 to 0.45, we also have to go 1 index further. So we can be able to include the 0.45. And in this case, we have index 0, 1, 2, 3, 4, 5. So we have to say to index 5. And that way we can capture the 0.45 as you can see here. So that's another way you can be able to access items in a list by using a slice. You're getting a slice from that list, a slice. That's how you do it. Remember, you have a starting index and then you have an ending index. The starting index is inclusive. The ending index is exclusive, meaning that it won't be included in your slice. So that's a good concept. That's another good concept to understand. Another way for slicing is if you want, for instance, to get to slice from the beginning and to a certain index, then you can leave this 1 here, and then we can start from 1, 2, 3, 4, all the way to 0.45 because this is index. You can specify the ending index, but not specify the starting index. When you do that, you are telling Python that you want to start at the beginning of the list and you just want to provide the end where you want to end, slicing the list, and we say we want to end at index 5. So we start here 0, 1, 2, 3, 4, 5. So we end here, but since index 5 is not going to be included because it's the end in index, we're going to slice all that. We're going to slice 1, 2, 3, 0.98 and 0.45. If we click on run here, you see now we started at 1. We did not specify the starting index, and so Python says you want to start slicing from the beginning of the list, and that's what it does. So it's beautiful. Look at it. Very nice. You can also specify the beginning but not the end. Like for instance, if we say we want to start at 2, so this is 0, 1, so we can say 1 but not specify the end. So we're telling Python we want to start our slice from index 1 all the way to the end of the list, and if I click on run here, we start at index 1, which is, in our case here, is 2, and we go all the way to the last index, which is our dictionary, as you can see from here. Oh, beautiful. How beautiful is that? If you want to access, you can also have the columns, and this will give you every item in the list. So if you want to access all the items in the list, you can just say, you don't specify the starting, you don't specify the end, it just prints for you all the items in the list. Remember, we have the columns in there, and that's how you can be able to access all the items in a list. And that's really, really beautiful. That's how, like, Python, it's just a very beautiful programming language, and it's very versatile. It gives you a lot of flexibility on how to do things. Another thing that I wanted to show you is about, we say that Python lists are mutable, meaning that you can change items in a list after you've created the list. You can add a new item, remove an item from a list, or change the value of an existing item in a list, and all that. So I wanted to show you how you can be able to do that. Number one, I wanted to show you how you can change the items in a list. Change the items in a list. Suppose we want to change this item here, hello world, and we don't want to use hello world. We want to use hello America. Hello America. So to do that, you have to get the index of that item. Remember, indexing is very important in lists, and we start at index 0. So this is index 0, index 1, index 2, index 3, index 4, index 5, and our hello world is index 6. So we can come here and say my list, and we go to that index 6 like that. So if I print this now, if I print my list index 6, that's gonna be print. Come on, print. If I print my list index 6 like that, so if I print my list index 6 and I click on run, we're gonna get that hello world, but I want to change it. So to change it, you can come here and you say my list index 6, and you assign this to whatever else you want this to be. And this is, remember, it's a list. I also want to just keep it as a list, so I'm gonna put that to denote the list, and then inside this I'll say hello America. I want to write America like that. And if I now print my list index 6, it's going to be hello America like that. So you see, it's now hello America. If I print all the items on my list, if I print my list like that, I can print all, and now hello world has been changed to hello America here. And that's how you can change items. You can change items in a list. You can modify a list that way. So most important thing to note is that you access the index of the item that you want to change, and then you can assign it to the new value. And now my list is changed. It's changed. Instead of hello world, it's now hello America. But that's how you can be able to modify items in a list and change an element in a list, like that. You can also add elements to a list. So I'm gonna just leave my hello world as it is, and I won't change that index 6. And if I click on my list here, it's now back to hello world, and that's beautiful. But I wanted to see how we can be able to add elements in a list. You can add elements in a list using the append or the insert method. Append, this will normally add an item to the end of the list, and the insert method, it will insert an item at a specified index. You specify the index, and then the item will be added at that index that you have specified. To add an item using append, you can say, like, for instance, you use the name of the list. You can say my list, then you say dot append, and then you specify what you want to append. At the end here, I want to add another dictionary, or maybe to make it a little bit easier, instead of adding a dictionary, we can add the number 9, like that. And if I click on run now here, our list has an item appended at the end. Remember, append puts the item at the end of the list. So now my list here has, we are printing my list here, and it's printing 9 at the end. See, it prints 9. It prints 9 at the end, and that's how you use the append method. Append method. Append method, it's a method. Append method in lists. That's how you use the append method in lists. And then we can also add an item to a list by using an insert method. Insert method will normally insert an item at a specified index. Suppose in index 0, 1, 2, index 2 where there is 3, I want to add a string by the name of a string with hello America. Then I can come here and I can say insert. So it's also a method, so we use the parentheses like that, and I specify the index where I want to insert. This is going to be insert, my list dot insert, and then I specify the index where I want to insert the item that I want to add. So we have 0, 1, index 1, index 2. I want to insert in index 2. So I come here, I say the index is 2, then a comma, then I specify what I want to insert. I say hello. I don't know why it's giving me this. I don't want it. Insert. And then I say we insert at index 2, and what I want to insert is hello America. Hello. I don't know why it's keeping me that, but it's just telling me that's an object, which I already know. Hello America. And if now I click on run here at index 2 where there was 3, we have hello America index 2. We have index 0, 1, 2, we have hello America. And that's how you use the insert method how you use the insert method to a list. Use the insert method. That's how you use the insert method. You use the insert method when working with a list. You can specify any index, and this is the index, and this is the object. It can be anything. In our case, it's a string. And if you're wondering, a string is an object? Yes. Everything in Python is an object, and that's beautiful. Everything is an object. And we will learn more about this as we continue with Python all day. We will see that everything in Python is an object. Everything, including our list, it's an object. And it's really beautiful, but that's how we can be able to add an item in a list. You can either use append, which normally is going to put the item that you append to the end of the list. And you can also use insert, but when you're using insert, you specify the index where you want the new item inserted, and the index in lists, rather pretty much indexing in anything iterable, most of the time indexing normally starts at 0. We start at 0, 1, 2, 3, like that, and it's beautiful. So that's how we can be able to add items to a list. And then another thing is, how can we remove items from a list? So to remove item from a list, we have different methods of removing items from a list. Number one, you can really use remove. You can use remove, and when you use remove, you just specify the item that you want to remove. Like for instance, if I want to remove my dictionary at the end here, I can just come here, my lists dot remove, and then I specify the item that I want to remove, and I want to remove this dictionary here, so I can just copy that and just put it there like that. And if I click on run, my list now does not have the dictionary, which is the end of the list. It doesn't have that dictionary. It's removed. And that's how you do it. That's how you can be able to remove. If I bring this print statement a little bit here, you can see before I remove it, it's there. So if I click on run, you can see the dictionary is there. This is before I removed it. This is this first print statement here. And then I said, let's go ahead and remove the dictionary. This is the dictionary here. I said I want to remove it, and after I removed it, I say print my list, and you can see here it doesn't have the dictionary. The dictionary has been removed. The dictionary has been removed from my list. And that's how you can be able to remove an item. That's how you can be able to remove an item from the list. There's another way to remove an item from a list, and it's called pop. It's called pop. And pop, normally what it does is that it removes an item from a specified index. Indexing is very, very important, and that's why I keep on repeating, start at index 0, know your indexes. It's very important. But if I want to remove an item from my list using pop, I'm going to take this back. and I'm going to take the insert here, so we can have our original list here with everything in it. And now if I wanted to remove an item from my list, using the pop method, it's just as easy as saying my list dot pop. And with pop, I have to specify the index of the item that I want to remove. Suppose I want to remove hello world. I have to find the index of hello world. So I start here. This is index 0. index 1, index 2, index 3, index 4, index 5, and a lower world is index 6. So I say pop, and this is a method. So we write 6. And if I now run this and I print my list, it's going to be printed without this because we popped this. We popped it out. Pop out of the list. And now if I print on my list, we don't have a lower world because we popped it out. As you can see from here, we have everything else but a lower world because we popped it, and by popping it, we actually removed that index. Remember, with pop you use index. We popped it out by utilizing the index of the item that we want to remove, and now it's no longer in our list. That's how you remove an item from a list. And I think just lists are very versatile, and they're also fun. They are fun to work with. That's how you can be able to remove an item from a list. You can either use the pop that we just saw, or you can use the other one that we saw, and that was the remove method. There is also another method that you can be able to utilize to remove an item from a list, and that is called delete method. But delete is D-E-L, delete, short for delete, del, D-E-L. And if, for instance, you want to remove an item from a list using the delete method, you just use delete. So I can say my list dot del for delete, short for delete. And now, oh sorry, not dot del, sorry. Actually we say delete, we say del, and then we specify the name of the list, like my list, and we want to delete not the whole list, but we want to delete you specify the index of what you want to delete. Suppose I want to delete the dictionary, so we can come here and we specify the dictionary. We specify the index of the dictionary item. This is 0, 1, 2, 3, 4, 5, 6, 7. This is index 7. We can say index 7. And if we click on run, our dictionary has been deleted from our list. If you see here, we don't have the dictionary, we have deleted it. So we use del, D-E-L, short for delete, and then we specify the list and we specify the item. Can we delete the all list? Let's see, delete the all list, and we click on run, and it doesn't allow for that. It doesn't allow for deleting the all list because name my list is not defined. Oh, I see. It actually does delete my list, but it deletes everything because now I get an error, and the error said name my list is not defined because we have deleted the all list. Another thing I wanted to show you, when we were removing the dictionary here, we started counting from here 1, 2, 3, and we said delete my list, and we said index 7, and we ran that and it removed it. But you can also accomplish this by, since this is the last item in the list, instead of counting from left to right, you can also count from right to left, but this is going to be negative wise. If you're going this way from left to from right to left, you have to use negative indexes because this is index 7, but it's also index -1. So you can say -1, and it's still the same thing. You accomplish the same thing. We still delete that dictionary is because the dictionary is the last item on the list, and it's also index -1. So when you are counting from right to left, you start with index -1, -2. So if you say -2, that will remove a lower world. -2, that will delete hello world. See, hello world is not there. We have deleted it. We can also, so you can count from 0, 1, 2, 3 for indexing. But if you start at the end, you start with index -1, -2, -3, -4, and so on. So you can access the items from a list either from left to right. In that case, you start with index 0, or you can start from the end to the beginning. In that case, you start with index -1, index -2, index -3, like that. And that's another concept that I wanted you to be aware of when working with lists. And we saw the list method, we saw the append method to add an item to the end of the list. We also saw the insert method where we specify the index where we want to insert an item in the list. We saw the remove method that is going to remove an item from a list. We have to specify the item that we want to remove. And we also saw the pop method that is going to remove an item from a specified index in the list. And then there's also another method called the clear method, which removes all items in a list, leaving it empty. So we saw the delete where we say delete, and then we say the name of the list and the item that we want to remove from the list. That's the index of the item that we want to remove from the list. We also have the clear method. So we can say here my list.clear. And then then if we click on run, now we're going to have an empty list. So our list now here is empty. So the delete, the del for delete, deleted the list, whereby when we click on print my list, it throws an error because the list itself, the whole thing including the name of the list, has been cleared or has been deleted. And so we don't have my list anymore, and that's why we got that error, because we are trying to print my list when we already deleted it. But the clear just removes the items, all the items in the list, leaving an empty list. As you can see here, we now have an empty list, and that is the clear method that you can use to remove all items, in the list. We also have another list method called index, and index method in a list will normally return the index of the first occurrence of a specified item. The first occurrence of a specified item, like for instance, you can say if you want to get the index of hello world, then you can just come here, we can say print my lists, and we can say my list, and we can say print index of, let's see here, we say print my list, and then we say dot index, and then we specify the index where we want to get the index of that. So we want to get the index of hello world. We have 0, 1, 2, 3, 4, 5, 6. So that's going to print for us 6, but we want the index of hello world. And when we click on run, we have 6. It returns the index of the item that you have specified inside the index. If we want the index of 1.5, obviously that's going to be 5. We can just come here, print index of 1.5, like that. And if we click on run, we have 5. If we want the index of 1, and we click on run, that's going to be 0. And now, for instance, if we have another 2 here, and another 2 here, and another 2 here, we want to print the index of 2. Since there are multiple 2's in our list, there is this 2. The first 2, 0, 1 is index 1. Then we have another 2 here and another 2 here and another 2 here. The index method normally returns the index of the first occurrence of the item that you specify inside the index. So it's going to return 1. So if I click on run, we have 1 because 1 is the index of the first occurrence of 2. It doesn't look at these other 2's. It just returns the index of the first occurrence of the first 2. We have 0 and then we have 1, and that's where we find our first 2, and that's why we get 1 here. So that's how you can be able to utilize index to return the index of the first occurrence of a specified item in a list. And then you can also use another method in list called count, and this returns the number of items, the number of times a specified items occurs in the list. Like our 2 here, it occurs 1, 2, 3, 4. So if I use the count method with my list, I say print my list, and then I say dot count, and then I specify the item that I want to count, and this is a method, so use parentheses. I say I want to count the occurrences of 2, and I click on run. Then I have 4 because 2 in my list occurs 1, 2, 3, 4 times. That's how we have 4 here, and that's how you can use the count method in the list. Let's now talk about another list method called sort. As you can see, I've modified my list a little bit to contain integers and the floating point numbers because I wanted to use the sort method, or rather to illustrate how we can be able to use the sort method when working with lists. The sort method will normally sort the list in ascending order. It sorts the list in ascending order. It modifies the list in place by sorting it in ascending order. For instance, now if I come here and I say, I don't know why this came there, but we can say here my lists dot sort. And then if I come here now and print my lists, then I click on run here to run. Then I have my list here printed down here in ascending order. Now we are starting, instead of starting from 1, we are starting from 0.45, 0.98 in ascending order, 1, 2, 2, 2, and 3, and all that. So that's how you can be able to use sort. You can be able to use the sort method in lists to sort the items in the list in ascending order. We also have another method called reverse, and reverse normally reverses the element of the list in place. So if I come here and I say my list dot reverse, and then I print my list, then it's gonna modify the order of the elements, and I click on run. We can now see we start with 1.5, 2, 2, 2. See, we have reversed the order in which the items occur. Reverse. It reverses the order in which the items occur, and that is the reverse method. The reverse method in Python lists. Then we also have another method called extend, and this extends the list by adding all items from an iterable. Iterable is essentially something that you can be able to iterate along in a for loop like iterate. And for instance, now suppose we have this list called my list, and we also have another list here called we have another list here called, or actually even maybe we don't need another list. If we just come here and we say my list dot extend, my list dot extend, and then we extend this with another list, we have to specify the iterable, something else that can be iterated step by step by step, next, 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 can be iterated along. A list is an iterable, so we can have a list, another list there, and we can also now add an item code, like say hello world. We can add our hello world, and after hello world we can also add a 7 2, and we can also add a dictionary here. We can add our dictionary back. We can add the name was John. We add a name, and the name was John. Remember, when we are creating dictionaries, we separate the contents of the key value pairs with a colon, and we can also have the age of John. We separate the items in a dictionary with a comma, so we can have age and colon. We can say the age is 25. And we had another thing in our dictionary before. Remember, we had whether John was married or not. Married, and this was false. False, like that. And now we are using the extend method to extend this list, my list, to include all this. So if I click on run now, my list now, which I'm printing, my list now has been extended to include my dictionary, to include the other, the hello world, and also to include the 7.2, and it's now one list. It's now one list. It's not two lists. It's now one list, and that's how you use the extend method to add more items to the list, and you extend from the end. So if you can see here, we added our hello world after the 1.5. So it's like we took all this and put it after the 1.5. We extended the list, and that's how we can be able to use the extend method. That's how we can use the extend method on the list, on Python lists, to be able to add more items to a list. This is where we code with fun, because Python is a lot of fun. So just a very happy programming language. Next, we'll talk about list comprehensions. And list comprehensions are a concise way to create a list. They allow you to generate new lists by transforming elements of an existing list into a single line of code, which makes your code more readable. I will show you here about list comprehensions. And suppose you want to get the squares of numbers. Like say you want to get the square of 2 is 4, the square of 4 is 16, the square of 16 is, you want to get the squares of different numbers. You can use list comprehensions in a single line of code or two for the print to get the squares of different numbers. Like for instance, I can say squares is assigned to, and this is going to be a list because we are talking about list comprehensions, and I can say x square is a number multiplied by itself, square, so we use double multiplication sign, and then we square this by 2, we raise this by 2, for, this is now the list comprehension for x in range, and we can specify the range, let's say from range 5. From range 5. We'll talk more about range, but the range, you know, from essentially from 0 to 5 with 5 not included, from 0 to 5 with 5 not included. And if I click on print squares, so this is going to be the range. We start from 0, 1, 2, 3, 4. 4 is the end. So we want to get, because we don't include 5, but we start at 0. So if I click on print squares here, and I click on run, then I'm going to get the square of 0 is 0, the square of 1 is 1, the square of 2 is 4, the square of 3 is 9, and the square of 4 is 16, because I said in range. Range means start at 0 and end at, in this case, 4, because we are starting at 0 and we need 5 items. So from 0 all the way to 4, we don't count the 5. It's like 5 minus 1. If we say range 6, then we are going to have 5 included, but 6 is not going to be included. So we start at 0 all the way to 6. And if we get the squares, we're going to get the square of 5, which is 25. It's going to be the end. If I say to 7, then we're going to get all the way to 6, and we have the square of 6, which is 36. If I say go all the way to 10, then we're going to get the square from range 10 is going to be from 0 all the way to 10, with 10 not included, so to 9, and we're going to have our last one is 81. But that's how you can be able to use, this is a list comprehension right there. It's actually a list, but inside the list there's a comprehension, there's the list comprehension, and that's how you can be able to create a list comprehension. Another one for list comprehension is that you can have a list comprehension with conditions. You can say, give me this if this condition applies to it. Like for instance, let's say you want to get the even numbers in a certain range. Like you want to get the even numbers in a certain range. The way you can do that, again, you can utilize list comprehension. We can have our list, and then we can use the conditions. And maybe we call this, we can say this, even numbers. We can call it even numbers. I have to take this print here. And we can say even numbers is assigned to a list comprehension. We have the list there. So that's first step. First steps first. The list comprehension, since you're creating a list comprehension, it has to be a list. So list comprehension, and we want even numbers, we can say x for x in range. Let's say our range now is from 0 to 9, which will be 10. You know, we want, because the last number, the last number is not included. So 10 is more like pretty much getting the even numbers between 0 and 9. 0 and 9, but we have to say 10 because the range starts at 0 and so it ends at 9. So this is the list comprehension. So now if I click this and I click on print even numbers, I'm going to get both even and odd numbers. So if I say print even numbers, and I click on run, we have our list comprehension. It's working, but it's printing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we just printed the range from 0 to 10, with 10 not included. So we ended up at 9 because we started at 0. If you count this, they are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are from 0 to 10, and 10 is not going to be included. And but we wanted to print the even numbers. We just want the even numbers. We don't want the odd numbers. We don't want 1, we don't want 3, we don't want 5, we don't want 7, we don't want 9. We just want the even numbers. So we have to put a condition. So this is list comprehension with condition. We put a condition, and in our condition is going to be so print x for x in range 10 if x modulus. The modulus operator says if you divide this number, if you divide the x by this number, the remainder must be 0. So the modulus gives you the remainder after division. So the remainder after division should be 0. And the way we say, we compare whether a number is equal to something, modulus is 0, like that. So this is the comparison sign. If x modulus, it should be modulus 2. If you divide this number by 2, the remainder is 0, because we want even numbers, and even numbers, if you divide an even number, the remainder after division is going to be 0, and that's how you get an even number. So, or you say a number is even, if you divide that number by 2, the remainder is 0. And the way we check for remainder after division is by using the modulus special operator for integers, the modulus special operator. So now if I click on print even and I click on run here, we're going to only get even numbers. We get 0, 2, 4, 6, 8. And that's how we can add conditions to a list comprehension. We have the list comprehension here, but we also have a condition. If x divided by 2 as a remainder of 0. So we use the modulus operator, which normally checks for the remainder. So this is the condition, and that condition we only print, it's only even number if the condition is true. If the number divided by 2 as a remainder of 0, and 0 divided by 2 as a remainder of 0, 2 divided by 2, there is no remainder, 4 divided by 2, there is no remainder, 6 divided by 2, there is no remainder, and 8 divided by 2, it's even. They are even numbers because when you divide them by 2, there is no remaining. The remainder is 0. There is nothing remaining. And that's how you can be able to use list comprehension to check if a number is even, for instance. There's many other different applications, but I think these are pretty simple applications that can also help us in understanding list comprehensions, and also list comprehensions with condition, if it's a condition, with condition. Already welcome again, to Python all day. This is what we do, just a lot of programming and having fun. And I just wanted, I think we went through a lot, and the video is getting a little bit longer. I did want to mention a lot of other methods and other ways to work with lists. And I think I'll make another advanced video at some point for advanced concepts on lists. But for now, I think I will stop here. And before I leave, I just want to let you know about some common pitfalls that you may encounter when working with the lists. And the most common pitfall that you will encounter is maybe when you try to reference something that's out of range. Like, for instance, if you wanted, or rather you want to access an item that's not in range within the list, like our list here has how many items, how many indexes. We have index 0, 1, 2, 3, 4, 5, 6, 7, 8. If you say you want to access my list item 10, then there's no item 10. There's no index 10 in this list because the list is 0, 1, 2, 3, 4, 5, 6, 7, 8. 8. Index 8 is the last index. So if I want to access index 10, then I'll get an error, obviously, because it's out of range. The list is out of range, and so you cannot access an item that is not there, and that's why you get the out of range list, out of range list, out of range error. So that's one very common pitfall that I see a lot when working with leads. You have to make sure that you are accessing an item, or rather an index of an item that is there. We can access index 0, index 1, index 2, index 3, index 4, index 5, all the way to index 8. But anything beyond 8 is out of range because we don't have our list does not have index 8, anything beyond index 8. And that's how you can be able to work with Python, leads. Be sure to subscribe to my YouTube channel because the world is a happy place and we're gonna be very happy. We're gonna be very happy together. Thank you guys. I appreciate it. I will see you in the next video, next episode. Bye bye.